Hi guys, it's Janek from Elympics, and in this video I'm going to talk about some basic ideas regarding server authoritative multiplayer. First, I would like to remind you that this tutorial, as well as many other useful resources, can be found in our documentation at docs.olympics.cc. This video will be more of a short talk rather than a tutorial, since we will be mostly just discussing theory required to help you to develop multiplayer games using our Unity plugin. Let's start with what server authoritative means. The easiest way to explain it is to compare it to its opposite approach to making multiplayer, the client authoritative. When connecting players with each other, as the developer, we have to decide how their games will communicate. In case of client authoritative, the players will calculate the effects of their actions locally and send that information to either a server or to other players directly. For example, when one player wants to move forward, they will calculate that their position has changed from 00 to 01 and send that newly calculated value to the server. The problem of this solution is that not everybody will play fair. They could analyze the web traffic and modify the data sent from the game. In case of movement, they could send any position they want, effectively teleporting around the map and giving them hugely unfair advantage. In some games, cheating isn't a huge problem, but in games focused more around PvP, it's pretty much guaranteed to ruin the player's experience. Those are the cases where it's almost always better to use the server authoritative approach. In this approach, the player will send the input to the server instead of the calculated world state. Server will then calculate the effects of their actions and send back the results it got. This allows us to be certain that the game state contained in the server instance is always correct. While ensuring fair gameplay is definitely helpful, it's not the only advantage of server authoritative. It's lighter on the client's bandwidth, since sent input data and received effects will usually be smaller than sending world state both ways. It is also less reliant on consumers' bandwidth than, for example, a peer-to-peer approach, since all players will be communicating with the server individually, so one of them having bad internet won't influence the experience of other players much. However good it may be, the server authoritative doesn't come without its own problems. Most common ones that people come across early on are the input lag that players experience, the download size of the world state sent by the server, and the workload it puts on the server machine. Thankfully, it's been around long enough for people to come up with some clever solutions, so let's take a look at them one by one. The input lag problem is caused by players sending their input to the server and then waiting for the response to see the results of their actions. It's very frustrating and ruins the game feel of fast-paced games completely. To the rescue come the concepts of prediction and reconciliation. When sending the input to the server, the client doesn't wait for the server and calculates the results by itself. This is what we call prediction. It allows the player to move instantly on his own screen. Most of the time, the results will be correct. However, sometimes the actions of other players, which we have no way of knowing, will influence the actual result. This is where the concept of reconciliation comes in. When the results from the server reach the client and find that the state it has calculated is incorrect, they will use the fact that the server is always right and impose that new state onto the client instance. This ties into the second problem, which is when the size of the state sent by the server is too big. This one has multiple solutions, but the most general one is to make sure that all of the information you're sending is really necessary. For example, if you're sending back the information about the health of the player. In case of killing a player, you could be sending the information about his HP, whether he's alive or dead, and whether his game object has been deactivated. Or you could just send the information about his current HP and let the client side figure out on its own that since it's below 0, the character should be killed and its game object turned off. Coincidentally, the solution to the third problem, the server's workload, is analogical. Analyze your project and find what does and doesn't have to be calculated by the server. Many things can be processed locally. First and foremost, pretty much anything concerning the aesthetics of a game. Player animations, particle effects, and other things concerning the visual side of the game should be turned off on the server instance and left to the client's machine to process. For other things that are happening in your game, it's a good rule of thumb to only leave crucial game logic to the server. The final problem is one that I haven't mentioned before. It's the complexity of the task, which is designing the game to work well when playing online. Programming the prediction and reconciliation, designing the server instance and player instance separately, and writing the networking are all very tricky, but our tool, Elympics, comes with most of them pre-programmed and easy to use. It allows you to make one game and simply select which parts of it should be predicted and synchronized, which parts should be run on the server and which on the client, and much more with a simple interface and an API. If you want to learn more about how to use it, we've got tutorials for setting up a project and testing your games locally already on the channel, and we've got more tutorials on the way. We encourage you to visit our website at olympics.cc, and if you've got any questions, join our community Discord, links in the description below, or put them in the comments below. Have a great day and thanks for watching!